Greetings to everyone. Today I am happy to host everyone on our panel discussion on floodings in Kazakhstan. Northwest Kazakhstan has declared a state of emergency after the worst floods in 80 years. The flooding was sparked by overly warm weather that caused mass snow melt across 10 regions of Kazakhstan. We, the Kazakh-European Science Association, under the leadership of Professor Serik Meiranov, Dr. Nurlan Mussabekova, and me, Aya Yazbolatova, offer a platform to discuss floods in Kazakhstan, challenges, solutions, and lessons learned with field experts from Netherlands, France, Kazakhstan, and Germany. Our speakers, Professor Fredrik Huthoff, Dr. Assel Mussabekova, Dr. Vadim Yapiyev, and Nurlan Ongdas will give their talk first, following by a Q&A session. We would like to ask everyone to write their questions or opinions in the chat, and we will address them shortly after the talks. I would give the word to our organizer, Professor Serik Meiranov.
Okay, thank you, Aya. Hello, everyone. Dear participants of the urgent panel discussion on flood response in Kazakhstan. On behalf of the organization committee, let me express my gratitude to all participants who joined this meeting. Despite for the short notice, our speakers instantly agreed to share their experience on this very important topic. So currently, there is a lot of information about this event in a mass media and from government. But today, we gather here to hear scientific opinions from professionals and researchers from different countries. Right now, the north and west regions of Kazakhstan are experiencing a second wave of floods in Kazakhstan. And the 2024 flood is unprecedented and the most, biggest one, as was mentioned by President Tokayev, and probably the biggest disaster in the scale for the past 80 years in the history of Kazakhstan. And according to the Ministry of Emergency Situation, the water level in the Jaik River, Ural, in the West Kazakhstan region is still elevated. Rescues are building protective dams and pumping water out of the flooded area. In North Kazakhstan region, the flood situation remains stably difficult. As the moderator Aya mentioned, today we have young but already distinguished experts in this topic. So let me first introduce our special guest, Fredrik Huthoff. He's a PhD associate professor, of hydraulic engineering at the University of Twente, Netherlands. According to the Times Higher Education ranking, this university is considered one of the top 200 most prestigious universities globally. He recently visited Kazakhstan to provide insights during the flood crisis in Kazakhstan. So as an expert in river morpho-hydrodynamics, environmental flows, and disaster management, so he has contributed to our program, Kazakhstan program. And his international work includes studies on river and coastal dynamics. So let's greet Fredrik Huthoff. Yes, hello. So please go ahead. Mike is yours. Stage is yours.
Okay. Well, thank you for that kind introduction. I'm going to now first try to share my screen. Let's see if that all works. I believe that is fine, correct? Yeah. Okay, so I'm going to present now. First, maybe a little bit of an introduction to my talk. So indeed, I have already been introduced, so I'm going to skip that. But I'm going to speak about what what we have done in Kazakhstan last week. I was in Astana. I arrived last week on Monday, and I was there most of the week. Towards the end, I went to Almaty, and it was quite a roller coaster. And I could talk about it for hours, what has happened and what we have done, but this is going to be a relatively quick run through. so you have an impression of what we did and the decisions we had to deal with. And yeah, in the end, some lessons learned maybe in general, and I invite you to come with questions and maybe, yeah, we can have a bit of a discussion. Okay. So, yeah, the first slide, it says here, the Dutch disaster risk reduction and surge support. That was the, let's say, the umbrella for which I visited Kazakhstan. It's a facility that is offered by the Netherlands government. There's a pool of experts pre-selected, and if some country in the world has a water-related disaster, you could, in principle, request support. So this has happened many times before in the past, and this now also happened for Kazakhstan. So I'll get into more details later, but so mobilization was made. I was available. I had a suitable profile, so I went out together with a colleague, Henk Nieboer, who also happens to be the honorary consul for Kazakhstan in the Netherlands. And he has a water background, so it made sense that we could go together. He has already trust relationships in Kazakhstan, and I was more the, let's say, technical expert and team leader. So that's a bit of could be involved, and I'm sure are interested to learn from this. So that is the end of my presentation. Maybe some final comments I would like to make, if I still have a couple of minutes. Do I still have a couple of minutes? Yes. I'm going to stop sharing now so you can see myself a little bit better. Yeah, so what do we really learn from this? I would say in a situation like this, in an emergency situation, of course, I'm a flood risk management expert. I know the types of models. I know the latest technologies that are out there, even with AI and very advanced stuff. And some of this is not being, not all of this is operational in Kazakhstan. But at the same time, it's also not all operational in the Netherlands or many other countries. These most advanced technologies, they require times of testing, and you need to be sure that you're using them in the right way. You need to train the people right. So even though you could question maybe the level of technology of what is operational now, it really does. Now it didn't make sense to replace it by anything else because you're disrupting the flow of decision making. And yeah, it could potentially be even more harmful than good if you, in such a situation, yeah, give a shock to the system in the way the emergency is being handled. And with their tools, they are doing the right thing. So that is, yeah, that is just a general message I want to say put out there. So you really have to distinguish between being a technical expert and being an emergency expert in what type of decision is the right one at this very moment. The other lesson personally is that I think we should all learn from this huge disaster that is happening. There's floods now also happening in China, also in Dubai. There's scales of floods and types of floods that we haven't really seen before. We understand some of the climate change trends. Warmer air can hold more water, so you have longer periods of droughts. But also, if that water is triggered to come out of the water or out of the air, you can have floods of scales that we have never seen before. And this is what has been happening now in Kazakhstan, and it won't be the last time that something of this overwhelming scale will happen, is my belief. And this could happen in Europe, this could happen in America, this can happen in many places around the world. So we should really learn from this and prepare for such devastating events in the future better. So thank you. That's my talk.
Thank you so much, Professor Huthoff. It was a really interesting talk on the challenges of the emergency situations. And we do have some questions, but if you are comfortable, we would like to leave them in the end during the Q&A session.
Yeah, that's fine.
And look to progress next to our speaker, Dr. Vadim Yapiyev. He's a PhD, he's a postdoctoral researcher at the School of Mining and Geoscience, Nazarbayev University. Dr. Yapiyev is an environmental scientist with a substantial field and lab experience. He is an experimentalist with a research focus on process-based modeling using environmental tracers such as stable water isotopes and sensor data to track the fluxes and stores of water, energy, and matter. His primary area is water resource research, and the current research domain is critical zone and land surface processes. Please, Dr. Yapiyev, we give a word to you.
Okay, thank you. Can you hear me? Can you see my presentation? Because yeah, can you see my presentation? Yeah. Okay, thank you. Just maybe it's my short talk will be like a warm-up for Nurlan talks about more in detail about the causes of the current floods. I'm just trying to give you more water basin perspective on this area generally. Okay. So this you see the Kazakhstan water management basin. So you can see Serik, Caspian, Tabul, Turgai, Yesil, Nuras, Arasu, Irtis. So these are areas we are be talking about. So they are on the north, Ural, Sirdarya, Shutalas, Volkhash, Alakol, which are on the south. These are kind of two different hydrological regions in Kazakhstan. So last year with Nurlan, we wrote a proposal on the what's called North Central Asia, North Kazakhstan basin. This is actually the most of the basins which were flooded. So what are the characteristics of this basin? So these are pluvial nival regime basins. So you have the cycles of precipitation and temperature peaking in summer. So so they are liquid precipitation, rain, and snow. So they are irrigated agriculture mostly, or and animal husbandry. So if you could see here, the main divide is Ural Mountains. So there we have Ural Sheikh flowing to the Caspian Sea, direction of Caspian Sea, and we have the other basins like Tabol, Yesil, and Irtis. Flowing to from south to north to the North Sea. So, and the other basin is Torgai, Sarasu, Nura, which are currently, particularly Torgai, Sarasu, which have dry and have almost no runoff. So they're in the center. They're characterized by dry and cold condition. This change most of the areas which is flooded with a BSK is arid cold steppe is a semi-arid area, transitional zone. So, and on the lowlands in the center of the Kazakhstan, we have cold and dry, arid deserts, so lowlands. So here, though the winter precipitation is small, it's very important for flow and recharge. So last year we started the project on headwaters of Yesil River Basin, which before headwaters in on large Yesil River, before the Astana Reservoir, which is the main water supply for Astana. So here you can see the hydrograph for based on flow data, seasonal hydrograph based on the flow data from 1980 to 1921. And you can see this peak in April of the flow, the mean flow. This is the main water flow happened in this snow melt period, and this is the maximum snow we can see. This is can be very high. So according to the old studies and our current research, this spring snow melt period provides like 70–80% of the annual flow. So that's also provide a substantial amount of groundwater recharge. So in several years ago, in 2021, I just gave a talk, and there are some excerpts of this. This Regional Environmental Center for Central Asia, they conducted water basin research. These are some excerpts. So they did hydrology assessment, and these are the results published in 2019. where they actually already predicted the change that we have. Yeah, so their peak seasonal flow in the spring will increase, and there will be more flooding in the lowlands. So that's in the processes that we have seen now, that the frozen soil, ice formation, they already been predicted. Yeah. So this is they also kind of started one of the tributaries considered flooded, Zhabaya River at Basar. So they already made the prediction about the high occurrence of flood events caused by climate change in this river. So this is a paper actually from Vlast in 2000, published 2021, which this city Atbasar, which shows that the flooding is a constant problem already in recent years. So this is not new. So that's their conclusion. So there will be increase in precipitation, increase in water flow, and they said one of the reasons they say there will be more prolonged period from March to April. Yeah, so there will be earlier melting of snow and more flooding. Oh, this already been substantial research on this topic in Kazakhstan. So the information was available. So the same group from Potsdam, Yulia Didovets, published recently a paper which they did more substantial assessment of all Central Asia, but also for Uralgic rivers, this Shagan, Derkul. These are tributaries of Ural River and Tabol, and they try to understand how climate change actually impacts the precipitation in discharge. This is a red lines is with climate change, and blue, I think green lines show that without climate change, they removed anthropogenic forces. They say that this Derkul in Japan, particularly the climate change effect made more precipitation and more higher flows. So this already we see the impact of climate change in this flow. So this quote from the research: our results confirm that climate change would lead to increase in frequency of hydrological extremes like floods, especially in northern part of Kazakhstan. So this some part of my research on Borabay lakes in North Kazakhstan, yeah, in the Sil River Basin, or somewhere in Irtysh, the Sil River Basin, which I analyzed the frequency of extreme climate from baseline period based on Shuchinsky weather station, 1935 to the period that I studied detailed water balance of lakes. And what it happens to be that during this period, 2008, 2016, we could have a very dry phase where we had heat wave years, 2008, 2010, 2012, and then we had a wet phase with the 2013 to 2016 and on, where we had a lot of increase in precipitation and actually increase in water levels in the lakes. So one of the conclusions from my work was that we have an increase in extreme events. So this for dry years and wet years, they're higher frequency. It's also that's analysis of precipitation events, particularly in 2013, 2016, we had very extreme precipitation during a hydrological year and during the winter period. So I also would just briefly mention there's some parallels. I was invited to a couple of talks about forest fires and the cause of climate change forest fires. And there was a forest fire in 2022 in Kostanay, and there was a problem. There were, a lot of forest was burned, and my opinion was that the heat waves it's causing the drying the vegetation and cause the fires. But next year, I remember there was again the fire, and there was much more devastating, and there were people died in the Vaya region, in spring in May 2023, and there was much more problem with the fire, and it was a catastrophic. So I'm just coming back to because in last year, Kazakh-Hydromet, they forecasted already there will be floods in 2023. Yeah, this is just excerpt, and they say we are not ready, and it's kind of, but I'm drawing the parallel. There was like a warning, so that's near miss, and then we had like a catastrophic event. In the one case is a forest fires, in one year we have the flooding. So and also briefly I'll mention that I did some review of the research which showed that there is like understanding though. So they did dam stability assessment. When I was reviewing the project, I asked the representatives of the ministry and are you transferring this understanding of hydraulic structure stability to the actual operational people who operate in the dam? They say no. So there is no process on transfer of this knowledge, this research into the practice to practitioners. So I'm not. This is just a brief summary. This is more of hypothesis because most of what happened we don't know. I think they already currently show there's an increase in precipitation, increase in flooding, and I think this 2024 is a compound event. So Nurlan will talk more in detail about what's actually the causes of this. So there may be like perfect storm, yeah. And I think what is needed is conduct more research on the basin scale, but also work on the disaster response, yeah. And we need more climate resilient infrastructure. The current, as Professor Huthoff already said, that these problems everywhere, and so we need more climate resilient infrastructure that would absorb such climate shocks. Yeah, and also in these basins we need cooperation with Russia. Yeah, research. Just thank you.
Thank you, Dr. Yapiyev, for your talk. We would like to go through the next speaker. The next speaker is Nurlan Ongdas. He's a doctoral researcher at the Department of Hydrosciences, University of Dresden. Ongdas is currently pursuing a PhD. The expertise lies in the hydrologic and hydraulic modeling of catchments and flooding events. Alongside his Kazakh and German colleagues, Nurlan is investigating urban water management challenges and hydrological systems in long-term settings, utilizing environmental tracers, sensor data, and advanced hydrologic modeling.
Okay, I hope everyone can hear me well. My name is Nurlan Ongdas, and in this short presentation, I would like to give some information about the potential causes of the current flood and what could be potentially done for the future and the recommendations and stuff. So, as you might all have noticed, that the recent floods have mostly affected the northern part of the Kazakhstan. And just for the purpose of analysis, I took some data on meteor data, temperature and precipitation from the Kazakh-Hydromet for the certain stations located in the northern Kazakhstan, as you can see from the map on the top right. And these stations cover a wide range of land, from the west to the east and from the center to the north of the Kazakhstan. And what's interesting is that even though they are located very far apart from each other, you can see that in terms of maximum daily temperatures, they have similar patterns, So what happened was that so the data is from October of last year until the end of January of this year. So we had a slow and steady winter coming. It's not usual for our part, at least I'm speaking for the Astana, because usually in November and December we already had a cold temperature and it's already freezing cold, But what happened last year was that even November and December were relatively warm, and we had some events, as you can see from the graph below, of different variability, I guess, depending on the station, but they have a similarity. So then suddenly in December we had a cold frost, and preceding this cold frost, we had a precipitation event. And this happened after this freezing. We had warming at the end of the year, and after this warming, we had another cooling in January. And this is only data for the end of January, but if we make it longer, according to our meteor station, we see that in February we had another fluctuation. So beginning of February, we had a warming positive temperature, and then it froze again. And also at that time we had this precipitation event just before the freezing period, cold period. And then what else is that we had some rain on snow events because the temperature was, air temperature was positive, it was warm, so we had rain on snow events. And what was the end of result of this unusual winter? You can see on these two photos. So these are the photos from the northern Kazakhstan, from our study area. So the right one shows the result. It's now the snowpack more or less resembles like a multi-layered cake, because this freezing warming resulted in these like different layers of the ice frost, and these are clearly seen on the picture on your left. The right one shows another consequence. It's the ice crust at the bottom of the snowpack, so on the ground, and so we have this ice crust which acts like some kind of insulation. And when the spring came, when the snow started melting, the water which used to infiltrate to some extent was, it could not infiltrate the soil, and it has to go somewhere. It goes down the slope and resulted in the accumulation of the flood wave, and resulted in the final flooding of the settlements, along the floodplains. So this is just some observations that we have for the current year because of its unusuality. And now quickly, I would like to go through the, let's say, future steps which can be or should be taken, in my opinion. The order of these suggestions are not prioritized, they're not in the order of importance, in random order, just letting you know. The first thing, in my opinion, one of the important things, the recent, in 2020, the Sarduba Dam, which collapsed in Uzbekistan, the Ost Dam, which collapsed in Russia this year, the dam in Aktobe region, which flooded, which collapsed and dam breached, and caused some flooding events in the Aktobe region. I think we don't have a clear, the current system does not take into consideration the flooding caused by the hydraulic structures. And I think some of them cause a high risk because they were mostly built during the Soviet time, and the exploitation operation, it's been quite a while since they went in reconstruction. And because of that, they pose a high risk. And for them, I think it's important to do some dam breach flood hazard mapping, as was done in this case. This is for the Astaninska reservoir, located upstream Astana. And what this thing will give you, such, let's say, work, is that it will allow authorities, any other stakeholders, emergency situation ministries, people to plan emergency action plans and to estimate flooding, inundation, the flood depth, wave velocity, how much time do they have, and it will tell them, it will help them to plan flood protection measures properly, or flood management measures properly. Okay, that's for the dam breach modeling. Another case, this is for riverine flooding. I would say most of the settlements which were flooded this year are located in the floodplains. People should understand that if a settlement or if the housing is in the floodplain, it will always have a risk of being flooded. And for that, it's important to estimate flood hazard due to extreme flows, like high flows. And this is one of the examples. Here all the infrastructure, roads, railway station, the housing, everything is being considered, and flood hydrograph of a certain return period is being simulated. Just like the previous example, this will tell the authorities to know which specific areas have a higher chance of being flooded, and what can be done, by modifying the model. I would say they can estimate what kind of work should be done to reduce the negative consequences. From my point of view, or at least from what I've heard and what I've read so far, I think that all the work which is being done in, let's say, in Atrau, Ural, and so on, is is not kind of backed up by some modeling or engineer-based evidences. So all of them is being done either considering the past events, let's say from 1994 or 2017, which you cannot solely base on because this year's flooding events they exceed the previous historical events. As a result, you have to, I mean, many things have changed since those times, you know, like maybe new dams or new houses, and therefore, like, I believe that such works should be done to efficiently use the resources, you know, and to estimate, like, to know what kind of flood depth you should be expected and what kind of damage and how firm or how stable your damage should be, instead of like just basing on someone's, let's say, solutions, assumptions, ideas in terms of which place will be flooded. Okay. Another type of flooding which is common for Kazakh cities is the urban floods due to heavy storms, you know, rainfall events. And these are some pictures I guess you've seen for Astana, our capital city. Like every year during summer or even this spring, we had some flooding events. And in this case, my suggestion would be I think the conventional stormwater management systems have some drawbacks at the moment, considering, as was mentioned earlier, about the influence of the climate change and other factors. And for that, I think it's recommended to integrate some nature-based solutions into stormwater management systems, like this well, you know, like the sustainable urban drainage systems, so-called, for mitigating the flood risk. And another suggestion would be that it is needed, we have to update, let's say, maybe improve to some extent the construction and design regulation that we have. I mean, and city planning as well should be changed. You know, if you want these things to have low risk or to reduce the negative consequences. Okay, this page will be kind of overloaded, but I will try to be quick. So another thing that I think is important is that should be further improvement of the environmental monitoring network of Kazakh-Hydromet. Yeah, I mean, they've been providing all the monitoring so far, but I think it is recommended to improve their capacity. For example, here we have a research test field in the campus of Nazarbayev University for the Tereza project, German Kazakh project Tereza. And here the graphs show, the top one shows the soil moisture and the bottom one shows the soil temperature. And what is interesting here is that, if you see, there is a gray line at the top, there is a rise, you know. The first thing which is interesting is this one, because this rise corresponds to the November. So in other words, in November, we had some infiltration, which is not usual for the Astana. And the second interesting point is that there was a saturation, I mean, yeah, to some extent, and the soil quickly drained this moisture. It did not keep it for a long time, and it drained very fast. So this is the second thing. And the third point is the graph below. You can see the temperature, that the gray line, which is the top sensor, how cold frost reaches the sensor, you know. So in a very short period of time, the freezing of the soil can be very fast. So in the case of this current flood, I mean, there are many factors, but one of them, I mean, one of the main ones, I think, it's the climate factors, which have played a major role. But without, let's say, consistently monitoring other factors which influence the soil moisture, soil temperature, I mean, like in a higher resolution, it's hard to like fully understand the scale and to understand the processes which have brought to the current extreme flood. And in addition to the improvement of Kazakh-Hydromet monitoring network, I think there should be a intensive involvement of the research community to study. There are a lot more topics that I have written here, but the snowmelt process in general in northern Kazakhstan, the snow transport due to wind infiltration processes, ice jamming in the river hydraulics, reservoir operation, optimization, they all have like interesting potential, you know, to improve the flood mitigation capacity of the country. And to give you the final two ideas, I think I'm not going to stop on them very much because it will be kind of difficult and will take too much time. But I believe that hydrological models should be extensively used all over the country. I mean, it needs a lot of capacity and so on, but I think it should be one of the plans to do it, and not only by the hydrological models, but other deep learning methods and so on. And the last but not least, but the most important, is that for each catchment, I believe like flood early warning system should be developed, which integrates the high resolution monitoring of the catchment, the stream forecasting, hydrological models, plus hydraulic modeling, and so on. And based on that, flood risk management strategy should be developed for each of the catchments which have been severely affected. And we should understand that these events, it's just a matter of probability. Every year has a certain probability of flooding events happening, and in the future, such things will happen anyway. No one can say for 100% being sure that these things will not happen anymore. But it just needs to be, this risk, the hazard should be, probability should be estimated, and measures should be taken accordingly. And with this, I hope I made it in 10 minutes. I thank you for your attention.
Thank you so much, Nurlan, for sharing your expertise and opinion on the types of flooding, causes, and measurements to prevent such emergency situations in the future. And I am happy to introduce our last speaker. Our last speaker is Dr. Assel Mussabekova. She received her PhD in molecular biology from University of Strasbourg, France in 2019. After her PhD defense, she switched from academic research to science communication and evidence-based advocacy. She worked as a science communicator and science journalist since 2020, served as a national immunization consultant to UNICEF Kazakhstan for 2 years, conducting several studies in the field of vaccine-preventable diseases in Kazakhstan in response to a measles outbreak. Currently, Assel is working as a technical consultant to the communication campaign on One Health-related issues and infection threats led by UNICEF Kazakhstan. Please, we welcome you.
Thank you very much for presenting me. Do you hear me well, and do you see the slide? Everything is fine, right? Okay, just let me know if something goes wrong. And also, it is at the end quite big, the presentation, so please do let me know when I have 1 minute left, okay? So I'm going to speak about hidden dangers of floods in Kazakhstan, and particularly about infections. So why we're speaking about infections in terms of floods? Obviously, when you have evacuation and displacement of people, you have low hygiene, you have high transmission risk because you have a lot of people in one place, you have a lot of stress, malnutrition, risk of injury, and also you have problems with water supply and food safety. So all of this, any disaster will lead to more infections, and this is for sure. But also there are so we can mention that during this disaster that we are having at the moment in Kazakhstan, more than 118,000 people were evacuated and displaced. When we have floods, we have also some specific concerns about infectious diseases. So first of all, flood water. Flood water itself is a hazard because it contains waste, trash, human and livestock waste, any kind of waste which can contain infections. Also, it contains sharp objects, so it will give you more risk of injury. It can contain bodies of wild or stray animals. And also, upon coming back home, these people who were evacuated, they will come back to a house or an apartment which is different from what it was before. So you can have more risk of humidity. So the objects, the food, the bedding can be contaminated, and you can have more risk of fungal infections. So which exactly infections and who is at risk? So when you have the evacuation, displacement of people, you basically increase the risk of all of the infections, especially we're speaking about very highly contagious infections, which are going on at the moment in Kazakhstan. So I remind you that we have ongoing measles outbreak, we have ongoing whooping cough outbreak, and we have very low vaccine coverage. We also have more injury risk, so we can have tetanus risk. This is an infection which you can receive from anywhere as soon as you have injury, and also the risk of skin infections. So the unvaccinated people are at risk for sure, and also people with chronic conditions, which will have more complications with any infectious diseases. Then when we're speaking about flood water, we can say that you have more chances to get diarrhea, and this can be caused by viral or bacterial diseases, starting from poliomyelitis as well, like enterovirus, to more simple pathogens like rotaviruses, noroviruses. You can also have salmonella, you can have different like dysentery, all of these bacterial diarrheal diseases. Also, the second group is zoonotic diseases, because you have basically the place where everything is mixed up. You have bodies of the animals, you have livestock, you have the flood water, which can bring you all of the remainings of the animals, which gives you a lot more risk of zoonotic infections. And also even imported infections from the outside can be at risk. So I can remind you about 3 weeks ago, we had cholera case, which was imported to Kazakhstan and which was happily localized. But things like cholera in the context of flooding is a recipe for a disaster outbreak of infection. Also, we have some regional infections in Kazakhstan, like specific for Kazakhstan. So Kazakhstan is the biggest reservoir of plague on earth, like 40% of the territory of Kazakhstan. You have under the soil, you have rodents which are transmitting, might be transmitting plague, for example. This is not to scare you, but this is just to give you the context of the geographical situation of Kazakhstan. And also we have diseases like anthrax, for example. And anthrax is tricky because this is a pathogen where the spores of this pathogen can live very long time, so hundreds of years, and they can still be viable and transmissible after many, many years. So in the soil. So the problem with flooding is that flood water is like there is a lot of surface area, right, covered with the flood water. And what it does, it brings the spores of the anthrax up to the surface of the soil, and it can transmit it like to big territories, including the places where you will have livestock, the crops, for example. And this all is the aftermath of floods. There are many publications on that it's quite common that veterinary anthrax outbreaks were actually beginning after flooding. So if you want some data about this anthrax burial grounds, we have around 2,300 and 400 cattle burial grounds, and many of them are not made according to sanitary regulations. So because they usually should be covered with so they should be on the certain like distance from the surface, they should be covered by beton, and then like not many of them are actually made correctly. That's why this is something that is under control at the moment of the Ministry of Health. So when we speak about these zoonoses, diarrheal diseases, of course, we're going to speak about the concept of One Health, because human health depends on the animal health, depends on the healthy environment. And it will become more and more important with the climate change, because we're going to have more and more natural disasters like this. So which infections exactly and who is at risk? We have spoken about these diarrheal and zoonotic diseases. And finally, we have the aftermath, so post-flooding. And we have a big risk of humidity and contamination upon returning home. So imagine people who return to the house like that, they will have the objects which are contaminated, they will have the humidity and the water which was there for a long time, so they will have bigger risks of fungal infections and other respiratory infections. So as of April the 6th this year, the Ministry of Health has reported that more than 1,000 epidemiologically relevant sites were flooded in Kazakhstan. And a lot of infection control is on place, but it is a very, very challenging task, because out of these 1,000 sites, you have cattle burial grounds, you have, for example, the toilets, and in the rural areas, you have water supply. and you have wastewater as well. So all of this mixed together with the flood water, and it's very, very difficult to control at the moment. So when we are speaking about the recommendations in this context, I want to put the infectious diseases in the context of the disaster cycle, because what I see, we have infection prevention control measures, but they're not exactly put, to my opinion, in the context of the disaster cycle. So disaster cycle is when you have the prevention and mitigation. So you are basically preparing the resilience of the system to prevent or mitigate these disasters. Then you have preparedness. You know that it's very likely that something is going to happen. So you are doing something to prepare for a specific disaster. Then the disaster happens, then we have the immediate response, and after we have the recovery. And then this cycle is, of course, repeated. That's why it is a cycle. So we are going to put the flood-related infection outbreak risks into this context. And as a prevention mitigation, we have to do the risk assessment. So for example, we have to think about our zoonotic diseases specific for Kazakhstan. We have to have effective infection prevention and control system in place already with the laboratories, with the staff, with the regional communication, etc., etc. Then when we speak about preparedness, we have to inspect shelters and prepare them, for example, as for the water supply and food supply and correct supplies of all of the hygiene needs. We have to develop this evacuation route so that they take into account the infection risks. And we have to think about, for example, the protective gear. So all of that has to be done before the actual disaster occurs. And when it occurs, then we also have to have effective communication in place, water supply, food hygiene supply, and outbreak response measures at place. So at every level, there should be outbreak response measures. So I'm going to talk a little bit about this after. And when we are speaking about the recovery, people should be coming back to a safe home. We should continue veterinary control, crop, soil, and water control long after the disaster. So for example, when we're speaking about anthrax, that is going to go probably to many, many kilometers away from the flooded area, we have to think about crop, soil, and water control. So also, when we speak about this context of disaster cycle, all of these measures, they should be done on different levels. We're starting from individual level, we go to community or organization. For example, we can talk about a hospital infection prevention and controls. And then we go to district, country, or even international levels. So to give you an example of how this measures, so we should do like sort of a mind map on all of these levels with all of these steps of the cycle. So when we're speaking on individual level, for example, and when we're speaking about recovery, so we have an individual which has asthma, which is coming back to her house, and this house is in water. Obviously, she's going to have a lot more risks of fungal respiratory infections than many other people, because she already has a chronic condition which will give more complications. So this kind of stuff we should think about on individual level. Then we're speaking about, for example, community level. And we know that during the response in a certain shelter, the vaccination coverage for a whooping cough is 40%. So it's very low. We are likely to have the outbreak in this shelter. So in order to control this infection in this community, we can have special vaccination campaign in this community, for example. So I'm giving you just the examples of how on this map we can work with different strategies. So, or if we're speaking about prevention mitigation on a country level or a district level, we can speak, for example, about zoonotic disease, which is called hemorrhagic fever Reno syndrome. It's very dangerous. It can be transmitted from the rodents, and it is very specific for West Kazakhstan region. So this is something that we should think about on a district level in West Kazakhstan, that this is a disease which is specific for this region, and in terms of flooding risk, it can give a lot of problems. So this is something that we could think about in the prevention and mitigation on this West Kazakhstan level, for example. And when we're speaking about the things that we should do, I like to divide this into 4 groups. First of all, it's legislation, because it's not only about laws, but also about algorithms and instructions on every level, which come from the government, which are official, even like how, like what drugs we buy for humanitarian aid, for example. We don't at the moment have these instructions, unfortunately. Secondly, we can speak about infrastructure and digital infrastructure as well. So we can speak about the sampling, the laboratories, of how they're present on every level. Of course, thirdly, with the capacity building, because we need a lot of staff, especially epidemiologists and people who can actually communicate these risks to the people who are evacuated. And finally, it's a communication perspective, so from individual to the state level and backwards. Also, we should have intersectorial communication, and it should be community centered. When we're speaking about communication, we should be 1 minute left, right?
I think we already passed the time.
Yeah, okay, that's why I asked to
Yeah.
Sure.
We can make it 1 minute.
30 seconds for conclusion.
30 seconds for conclusion. Okay. And so the problem is that many of the traditional methods of sampling, for example, so the main problem is how to localize the outbreak, and many traditional methods are not as effective as it might seem, and they are very costly, and the government at the moment is spending a lot of money and staff on sampling, which might not be as efficient. So we have to think about novel and cheaper approaches, such as sewage data, and also symptoms reporting, where we can use a lot of digital solutions. So with this, I'm concluding that we need a systemic approach, which includes clear communication strategy, which results in evidence-based innovative solutions, which is centered on minimizing the damage to human health. Thank you.
Thank you so much, Dr. Assel Mussabekova, and I'm happy now to move on to our Q&A session. We have several questions in the chat, and I would like to give a word to Ramjan, right, to choose the questions.
Yeah,
or if you want.
Thank you very much for speakers. It was an amazing session. Everyone prepared great presentations. So first question to Professor Fredrik Huthoff. So about consequences. So what's the consequences of flooding we expect in the coming months? Because we have droughtness, and what's your advice to government in such cases? Thank you.
Yeah, very good question. Well, I think for a large part, I have to agree with Dr. Mussabekova. I hope I said it correctly. Now, of course, the mess is here after the flood. Especially after such extreme floods, pretty much everything that has been flooded is now waste. Houses, you could consider waste, and so there's diseases coming. So you get issues of sanitation, waste management, also environmental aspects. Pollutants it's not only harmful to people, but the environmental consequences. So I think those are maybe the immediate things to be really concerned about. Yeah, the aftermath of the flood, the mess.
Thank you for your answer. And next question to Vadim Yapiyev. So Vadim, we saw your presentation. It's really great work that you guys have been done in Kazakhstan. So a question regarding the frequency. So you say that before we already have frequent several years of flooding in some regions, and now we have a big flooding. And so should we be aware of every year this kind of events will happen in future, or what's your expert opinion? Thank you.
Yeah, thank you. I'll just maybe comment on the previous question. So regarding the consequences. So what I said about dry and wet periods. So due to increased moisture recycling, so what we have wet period that will evaporate, maybe make wet summer, at least for the north of Kazakhstan. Regarding the frequency of events, I think there is better to Nurlan to answer this question because he's been doing flood modeling, especially for GSIL. But what research shows is this we cannot predict. Even the best modelers in the Netherlands or in Germany cannot predict. But we just say they are more high frequency, yeah, and they are compounding events. So this year we had like perfect storm, and what is actually was critical on this is we don't know. So we need to do more research, and what Nurlan maybe showed. So better modeling tools, and we cannot avoid this. There's more such events. Possibly next year's will be wet. Thank you.
Thank you, Vadim, for your answer. So next question to Nurlan. So there's a question from Yanina Kapersky. Sorry if I'm not pronouncing right, but she's saying like currently we see that there's a flow coming from Russian side. So big rivers from that mainly passing from Russia and coming to Kazakhstan. What about other regions of Kazakhstan? Might they have similar flooding in the near future? Let's say other parts of Kazakhstan. Thank you.
Just the way my colleague Vadim said, we are dividing the country into two types, I guess, main ones, the nival and glacial. So all the northern Kazakhstan might have a similar flooding event, but at the moment, I don't think anyone can say that if it's going to happen next year and how frequent. It's just a matter of probability, and you just need to, certain scenarios you have to estimate, like with simulations and so on, and estimate the potential inundation areas, water depth. And that, but at the moment, like as Vadim said, like this year was very unusual, and all these factors have resulted in these huge consequences. And for that to know for sure if it's going to happen next year for the specific region, again, you have to research, you have to monitor well, all the important factors, and maybe after that you can say like how much will be the the magnitude of the flood and so on.
Yeah, thank you, Nurlan. And for Assel, your presentation was amazing. I don't have here a question for you, but since one person asked, like, can I have your presentation? Maybe this person could approach you personally. Does anyone have a question for Assel presentation?
You can actually approach me via social media. I do a lot of communication work at the moment because actually, why I'm saying that we have to put it in the context of the disaster management, because there are things that should come first, as Fredrik already said, that you have response at the moment, and then you're going to have recovery, and then we can think about the system. So really, there are things that should come first, and now the communication about the infectious diseases is very important. People have to be aware of the risks, because the people who are being evacuated, for example, there were people, I read about the cases where they were trying to save their cattle. So they were trying even to collect the bodies of the cattle in order to receive the aid from the government. And this is completely something that is like, people are not realizing the risks of the infection zoonotic diseases at the moment. That's why they're doing such things where it's not of their fault. It's really of our responsibility as a specialist to communicate these risks. So, of course, you can have the presentation, and you can approach me via the social media.
Yeah, excuse me, Assel. So I found here's one question. So what's your comment about possibility of radiation contaminations? Thank you.
Radiation contamination is not my topic. So,
okay.
but I think mostly we have to speak about the flood water. So what can be in flood water? The problem is that in our country, for example, there are some regions which are contaminated, like where the soil is contaminated with heavy metals. So this is one of the examples of non-infectious threats, because this is not only infectious threats. So we have some chemical waste, we have some pollution, soil pollution. And when you have the soil pollution, this can all go to the floodwater. So there are studies about this as well. And that's why I'm saying that we have to really go region by region and thread by thread, and it should be very specific to the community, to the area, and the communication which goes to the community should be also specific for the area. because it's very like there is a lot of social and cultural context when we speak about this. There is a lot of in terms of poverty, like people are poor, like they're gonna come to the houses, they're not gonna throw away these mattresses, they're not gonna throw their bedding because they're poor. So that means that probably government should spend some money on providing all of this so that people accept this and so that they're living the healthier environment. So there is it's a very interesting and complicated topic. Yeah.
Thanks, Assel, for your comments. Vadim, please go ahead.
Yeah, just because I worked on water quality, I had a project, so a chemist by training. So I would just commend please understand this snowmelt pulse is very beneficial generally. What we have, for example, salinity in the Assel River, it's because of this highly diluted snowmelt. It's quite fresh, and actually this dilutes our dry regions. So my research on soil and Kazakh soils, for example, I conducted on soil contamination. We could not find any contaminated soils in North Kazakhstan or even in South Kazakhstan. So overall, I would say I do not expect any water quality problems in terms of the like natural quality in the water, but probably better water quality, better recharge, because snow melt is critical. But on the other hand, what we have now is a problem, is a lot of water supply system in big cities like Petropavlovsk and Ural, they are destroyed. And there are people now don't have the safe water to drink now. And there will be potential, like also sewage treatment networks also destroyed. There could be all this water supply and sanitation problems in urban centers. That's what I expect, and how quickly we can restore the supply in the municipal centers is one of the things that's in terms of water quality. Thank you.
Yeah, thank you, Vadim, for your comment. I think it's very important to know these knowledges over your studies. So I'm finishing this session of Q&A. If you have any questions, please reach out to speakers. Yep, thank you.
Yes. Okay, so I think we need to finalize, right?
Yes. Thank you, everyone. Thank you, all speakers, Professor Huthoff, Dr. Assel Mussabekova, Dr. Yapiyev, and Nurlan Ongdas for joining us today, sharing your expertise, sharing your opinions, and any suggestions how we can deal with this current situation and prevent it in the future. I also want to appreciate all of our attendees for joining us today, asking questions, and continuing the discussion. If you want to continue the discussion, ask any questions further, please reach out to our speakers directly, or I just post the links to our emails, social media links. We would appreciate your feedback. And I would also appreciate Dr. Meiranov and Dr. Nurlan Ongdas for organizing this panel session today. Thank you, everyone. I'll see you in the next event. Bye.
Thanks a lot. Bye-bye.